Alright, let's take a look at what a decimal number is, what a binary number is, and how to go back and forth between the two. Alright, a decimal number is a number you and I use every day to count with. So let's take the number 14. Okay, and how do we know what's a decimal number? Well, the base for all decimal numbers is 10. Alright, so how can we double check this guy and make sure he's out of the decimal? I'm going to take 4 times 10 to the 0. I'm going to take 1 times 10 to the first. 10 to the 0 is this position. 10 to the first is this position. If we had another one, we would have 10 squared. Okay, this is what we're going to multiply by. So 4 times 10 to the 0. Remember, 10 to the 0 is 1. 4 times 1 is 4. 10 to the first is 10. 10 times 1 is 10. If we combine these, 4 plus 10 is 14. So good. We are 14 decimal, and we usually denote that by writing 14 and then a small 10 right there, because this could be octal, something along those lines, maybe a hex. So we have to denote that this is a decimal number. So let's take this decimal number now and let's convert this guy, this is decimal here, to binary. Alright, this is a little different than the division you're used to, but we're going to take 14 and we're going to divide it by 2, because binary is 2. Bi means 2, and we're only dealing in terms of zeros or ones. Electronically, it's either on or it's off. We're either giving it voltage or we're not. Alright, so 14 divided by 2 is 7, and we have a remainder of 0. Now we got to go 7 divided by 2. 7 divided by 2, we're not trying to get a little decimal answer here. We're trying to get as close as we can with an exact. Alright, so 7 divided by 2 is 3. Okay? And we have a remainder of 1, because 2 times 3 is 6, then that extra 1 gets us to 7. So now we got to go 3 divided by 2. 3 divided by 2 is 1. And we have a remainder of 1. Alright, 2 times 1 is 2, plus that remainder 1 gives us 3. Now we have 1 divided by 2. In your world that you're used to, 1 divided by 2 is a half, or 0.5. In our world, 1 divided by 2 is 0, with a remainder of 1. Alright, it's very important. Remember, we're only dealing in ones and zeros. We're not going to have decimal places. So this is very important here. This is what we like to call our MSB, which stands for our most significant bit, and this is our LSB, which is our least significant bit. Alright? When we write the answer out, we write it from MSB to LSB. So our answer here is actually 1, 1, 1, 0. So this means 14. Let's verify it. Okay? So over here we're going to go binary to decimal. Alright, so we're going to take the same binary over here, which is 1, 1, 1, 0, and we're going to go to decimal with it. Now, in order to do that, the base for binary is 2. So we're going to take each one of these terms and multiply it by 2 to some power. Now, some power is based on the placeholder over here where it's sitting. Alright, so this is the 2 to the 0, 2 to the first, 2 to the second, 2 to the third. Okay, so this is going to take 0 times 2 to the 0. We're going to have 1, because that's this number here, this coefficient. This is times 2 to the first. This is 1 times 2 squared. And this is 1 times 2 cubed. Okay, 2 to the 0 is 1. 0 times 1 is 0. 2 to the first is 2. 2 times 1 is 2. 2 squared is 4, 4 times 1 is 4, and 2 cubed is 8, 8 times 1 is 8. If I combine all of these guys, 8 plus 4 plus 2 is 14. So we've successfully gone from binary back to the decimal that we know that we started with. Okay? This will never change. Here's a quicker method sometimes that you can get used to. If we start out with 1110, alright, and I'm just going to write these out the same way. But I know that 2 to the 0 is going to be 1. Okay, 2 to the first is going to be 2. 2 to the second is 4. This is going to be 8. The next one will be 16, 32, 64, 128, 256, and so on and so forth. So these are just our multipliers. Okay? I always know that 0 times 1 is 0. 2 times 1 is 2. 4 times 1 is 4. 8 times 1 is 8. So I can just add all these guys up, and that gives me 14 as well. So these numbers right here all stemmed from these numbers here. And that'll be significant. I'll show you in another video of how we can go binary to decimal with a larger number a little quicker using this method versus taking it and writing it all in this method.